Okay, welcome to Chapter 6, Part 4. We're going to cover a concept called molar mass. Now, I mentioned molar mass before, but now we're going to use molar mass of compounds, not just individual atoms. To find the molar mass of a compound, which if you recall, it is a collection of atoms, a whole bunch of them bound together. So let's take a look at the methane molecule. The methane molecule, if I break it apart, contains one carbon atom and 4 hydrogen atoms. So how are we going to find the molar mass, which is another way of saying how much does it weigh? Molar mass is the weight of a compound. So carbon in this case has, let's see, we got to find the molar mass of carbon. So the molar mass of carbon, well, you look on the handy-dandy periodic table, and it's 12.01 grams per mole. And, remember in math, and means plus, we have 4 hydrogen atoms. Now, I could take the molar mass of 1 at 1.008 grams per mole, and I know I could do that 4 times, plus, 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 but I could use fast addition, which is multiplication, because there's 4 of them. Well, then you just need to do the math. And you end up with a molar mass of methane of 16.04 grams per mole, and I'm running out of room here, grams per mole of methane. Sorry, that's squeezed in there. That's all there is to it. For number 9, we need to calculate the molar mass first of water. Well, yeah, you're going to have to find the chemical compounds for some of these. Ooh, Chapter 4, flashback. Water, you should know, is H2O. So for every 2 hydrogens, we're going to say 2 times 1.008. And I'm going to ignore the units for right now. They're all grams per mole because molar mass is grams per mole, always grams per mole. So 2 point that, and then we have 1 oxygen, just 1. So that's 1 times 16. When we put that together, we end up with 18.02 unit grams per mole. Molar mass, grams per mole. Okay, let's try the next one. We now have ammonia. Do you know what the formula is for ammonia? Well, that's okay. I'm about to tell you if you don't. You should know ammonium. Ammonium. That's one of the polyatomics you're supposed to know. Well, ammonia looks a lot like it, but since it's a compound, it doesn't have a charge. It has 1 less hydrogen with a charge of 0. Okay, well, the point today is molar mass. Nitrogen, how many nitrogens? 1. Times the mass of nitrogen, which is 14.01. And then we have hydrogen. How many do we have? 3 times 1.008. Plug that into your calculator. 17.034 grams per mole. And you could have just said 17.03. Speaking of sig figs, we do not count molar mass. Nope, don't do it. Don't count molar mass as part of sig figs. Think of it as a conversion unit between grams to moles. We don't use conversion units for sig figs. Okay, now that lecture is over, if you have any questions at this point, be sure to write them down so I can answer them tomorrow or today or whenever you watch the slide show. And let's try another one. Propane. Yeah, propane's one of those that, yes, like ammonia and water, you probably should know, but probably don't. I hope you do. But it's C3H8. Pause the video. See if you can find the molar mass of propane. Well, let's see. We have 3 carbons, so let's do the carbons first. We have 3 of those, and it's 12.01. And for hydrogen, we happen to have 8 of those, so that's 1.008. Plug that into your calculators, and you end up with 44.094. You could have just done that. Grams per mole. Yay, you're done. For this next one, it's glucose. I'm going to leave that one as an extra credit point. Both one, yes, you have to find the formula. You have to show the work on how you found the molar mass of glucose. You can't just write down the mass because you can also Google the mass. That's not a big deal. Okay, so the molar mass of sulfur dioxide. This one's kind of cool. Sulfur dioxide is a big problem in our atmosphere. It caused a lot of acid rain. You can see this picture here of the United States. Big problems with acid rain. That's all this dark stuff. And since we started using, I use that term loosely, scrubbers, we've managed to get a lot of the sulfur dioxide out of the air, and you can see that there's a improvement in the amount of acid rain. However, this sulfur dioxide reacts in the moisture to produce acid rain. So, we should probably have the question. We need the molar mass. We can do that. So the molar mass of sulfur trioxide, we should probably come up with a formula for sulfur trioxide. Sulfur trioxide, waiting for you to write the formula. Sulfur trioxide, there you go. All right, the molar mass. We have sulfur. There's only one of them. So that's 32.07 grams per mole. Oxygen, we happen to have 3 of them times 16. And now you just need to add it up. And so the molar mass of sulfur dioxide comes out to be 80.07 grams per mole. Easy peasy. Let's find the molar mass of this interesting substance known as PVC. All right, how many carbons do you have? If you said 2, you're correct. So carbon, we have 2 at 12.01 grams per mole. Actually, pause the video for each one of these and see if you can solve it on your own. See how you're doing. Anyway, for hydrogen then, we have 3 hydrogens at 1.008. And then we have to deal with chlorine. How many chlorines? 1. Go find the mass of chlorine. All right. 35.45. Now we just need to add it up. So you end up with 62.49 grams per mole. That of PVC. Well, we should write C2H3Cl. Okay, calcium carbonate is really cool. You find it in all of these pictures down here. But the first thing we need to do is calculate the molar mass of calcium carbonate, which means the first thing you're going to need to do is find the formula for calcium carbonate. See if you can do that. Pause the video. Calcium carbonate. Calcium carbonate. Well, if you came up with CaCO3, you're on the right path. Now, pause the video and see if you can find the molar mass of calcium carbonate on your own. I came up with a molar mass of 100.09 grams per mole. If you're not sure how I did that, make sure you put a note on your packet and talk to me about it later. Now, the next thing I want to know is, of course, because I'm not going to just leave the problem like that, of course things aren't going to stay that easy. No, now I need to find another thing to do. So if I have a sample of calcium carbonate, for whatever reason, it doesn't matter. I happen to have some sample of calcium carbonate. And what I want to know about this sample is how many grams I have. Well, I happen to know, and I'm not sure how this happened, but I happen to know that I have 4.86 moles of this substance, and I need mass. So the plan is going to be, make a plan, to go from moles to grams. To do that, I'm going to start with the 4.86 moles. And for every 1 mole, you have 100.09 grams. So you just take your calculator, 4.86 times 100.09, and you end up with a mass of we need sig figs, there's 3. So 486 grams of calcium carbonate. And you are done.